Hello, welcome back to Cracking the Cryptic and another fascinating puzzle today. I do want to mention the Padlocked Hunt on Patreon. That is the collection of Lockout Lines puzzles by really impressive constructors from the Discord server. That is worth looking at. I mean, the Discord server is always worth looking at anyway in its own right. But that Padlocked Hunt is something pretty special. We are getting final answers. I'm going to say trickling in because there's not a flood of them. There are some, and that is testament to how entertaining the puzzles are. But all of the original puzzles up to the last one are separately attemptable, and some of them are genuinely approachable. I mean, it's an interesting mix, to be honest. So do have a go at that if you're with us on Patreon. Also, we of course published our 400,000 subscribers treat video of us answering questions. Thank you so much for everybody who sent questions. Sorry if I failed to answer some of them properly, but it was quite good fun, I have to admit. I enjoyed the process. Now, let's have a look at this puzzle. This, I think, is a channel debut for Sotek, who has sent us some puzzles in the past and has been very active on Discord, and has also entered loads of the Patreon competitions. So, as well as all that, Sotek has conformed to all our preferences for sending puzzles in. So, why not? Let's have a look at this one, which is called Inner Sanctum. Now, there is one little killer clue. So this diagonal has to add up to 30. It can contain repeated digits, unlike the cages, which can't. So this cage adds up to 40 without any repeated digits, and normal Sudoku rules. And that's it, really. There's nothing else to it in terms of rules. I bet there's plenty to it in terms of puzzle, though. So do give it a try on the first link under the video. After that, in the description field are the links to all the other things that we're involved in, like our apps and our merchandise, and the book, and the Discord server, and the Patreon. Loads of stuff going on there. But this is the first one. So, Inner Sanctum by Sotek. Let's get cracking. Right, we've got some big cages in the middle. That 45 is obviously the total of all 9 cells, giving away the secret that 1 to 9 adds up to 45. These 42s, though, they give us somewhere to start. There are 2 of them, 1 on each side of the grid. And if you subtract 42 from 45, which we've just learned from that 45 cage, is the sum of 1 to 9, you get 3. And that means that in these columns, which must contain 1 to 9, the outside cells, the outies, have to be 1 and 2. And that's because this column must add up to 45, those cells add up to 42, the other 2 cells add up to 3, they must be 1 and 2. And that gives us a kind of double X-wing on 1s and 2s. And there's not much else going on, so that might be very useful. Okay, what I am going to do is observe that this 5 cage is either 1, 4 or 2, 3. Same with this one, obviously. There's a lot of symmetry here. Now the 6 cage is either 1, 5 or 2, 4. And that actually limits the 7 cage. It can't be 5, 2 now, because that would break the 6 cage in the same box. So the 7 cage is either 3, 4 or 1, 6. And we know that 1 has been used there, somewhere in those 4 cells. And maybe the whole puzzle is about where 1s and 2s can or can't be used. 1s especially, I think. Oh, hang on. Let's take these 5 columns now. Sorry, that's very odd highlighting. There we go. These 5 columns. They obviously contain 5 sets of the digits 1 to 9 in each column. Now, 45 times 5, quick, do it in your head. Yes, it's 225, I think. Yes, it is. Right, so those 5 columns add up to 225. Now, if we subtract the total of the cages, which is filling these cells, which might be the inner sanctum of the title. What do they add up to? Right, 40 and another 40 is 80. We've got a 45 and a 5, that's 50, that's 130. 139, 144, 150, 161, 168. We take that away from 225, a little bit of arithmetic in our heads. 57. I was hoping this was going to come out at 70 or something very close to it. 57 must be the total of the remaining cells in those columns, which are these pairs of 5 digits. That's not quite high enough to be exciting, I'm afraid, irritatingly. No, it doesn't get it done. That's a pain. But we do know that they add up to 57. Okay, I'm going to go back to what I was thinking about. I'm going to highlight cells that cannot be 1 or 2 now. So obviously in the 42 cages, they can't be 1 or 2. Just a fraction less obviously in rows 1 and 9. We have 7 cells each that now can't be 1 or 2 because the 1s and 2s are confined to these cells. Oh. These cells can't be 1 or 2 because that would require the remaining cell in the 14 cage to be an 11. These ones both can be. And that's interesting, isn't it? Is it? Yeah, okay. We know that this 40 cage, and obviously this one, they are 7 digits large. Now, what are the missing digits out of the numbers totaling 45? Well, there are 2 that add up to 5. So these cages are both missing either 1 and 4 or 2 and 3. And you can try that by adding up 9, 8, 7, 6 and 5, making 35. You know, there are only 2 fills for these cages. They are either 9, 8, 7, 6, 5, 4, 1 or 9, 8, 7, 6, 5, 3, 2. But the simple way to see that is by deducting 40 from 45, deducting 7 from 9 for the number of digits, and working out that 2 digits adding up to 5 are not in those cages. Yes, got it. That matters a lot in rows 2 and 8. So, where are 1 and 2 in this row? And you might say, well, you've only greened 3 cells, so they can appear in 6 different cells. And that's true. And we haven't ruled either 1 or 2 out of this cage. But we have ruled out that both of them appear in it, because either 1 and 4 are missing, or 2 and 3 are missing. So one of the digits 1 and 2 is missing from this cage, therefore can't appear in those 5 cells, therefore does appear here. And the same must be true in row 8. Yes, there's only 1, 1 or 2 in that group of cells, so the other for the row must be there. And now we can do all sorts of greening again. Well, actually, we get digits. Let's do that first. 1 and 2 is 3. That gives us an 8 there. 1 and 2 is 3. That gives us a 9 there. So now let's colour. Those can't be 1 and 2 anymore. These in boxes 3 and 9 can't be. I've got more than that because this can't be and this can't be. Why is that? That is because these 4 must contain a second one of 1 and 2 for the row. And that is the only one of 1 and 2 that can be in the 40 cage. Same's true up here with those. So these 2 are green as well. And now 1 and 2 are getting quite limited. Now look, we've got a set of 3 cells here that must contain 1 and 2. And that means the rest of this 45 cage doesn't. That's a huge chunk of green real estate. Now we've got to have a 1 and 2 in these 3 cells for box 4. This is lovely. So these 2 can't be 1 and 2. And therefore we know where they are in column 3. I suppose I could have seen that as soon as I did the 45. Oh no, 1 and 2 as a pair. But we still don't know which is which. Now we know these are green. They can't be 1 and 2. This is carrying on. I didn't realise. That can only have one of 1 and 2, so that must be 1 or 2. It can't be 2 because that would put a 7 in this central cage where we get our only given digit and it's suddenly helping us out. So now that must be a 2-3 pair. What about, yes, again down here we need 1 and 2 here. Only one of them can be there. This must be the other one. That's a 2 because that's an 11 cage, so we get a 9 there. Now, this cage doesn't contain 2 and 3, and that 1 resolves it. This cage is resolved by the 2. We said there had to be a 1 in these central squares, cells that are now white, so it now has to be here. 1 and 6. So this is 4 and 2, like that. And we can fill in 5 and 3. And we are away. And maybe this is the inner sanctum of the title, in fact. Maybe that's even more inner within this ring. Yeah, I was just immediately wondering there, by highlighting that, was it worth counting up this ring? Because we can work out what this total is by deducting 15 from 45. But that's only going to prove what we learned earlier, that these add up to 57. We learned that. So let's look at these top rows. 57 there, plus 1 and 2 is 60, plus 1 and 2 is 63, plus 8 and 9 is 80. Now the top row and the bottom row together must add up to 90 because they are both 45s. The secret is very useful in this puzzle. And that means these two cells add up to 10. Now they can't contain a 1 or a 2, so they're either 3, 7 or 4, 6. Now, we also know that these two cages add up to 28. If those two add up to 10 and those two add up to 3, these two add up to 15. And they're either a 9-6 pair or an 8-7 pair. Right, 2 can't be in these cells and 1 can't be in those. So we've got a pair of little X-wings. 1's there and 2's there. Oh, and I think that means that these cells have to be 1 and 2. Yeah, one of them, if you look at the 1 X-wing, you can see that it's either a diagonal pair like that or a diagonal pair like that. And in both cases, one of those two cells contains a 1. It's the same for 2's. So there must be a 1 and a 2 in those two cells. I'd forgotten that I could keep greening. I mean, I'm not sure there's any point anymore, but let's make those green because they're not 1's and 2's and just keep on going. I mean, I can't finish off the colouring on those, as far as I can see anyway. But it's been very useful, frankly. And we know this pair adds to 10 and this pair adds to 15. And what else? I mean, this is a group of 3, 4, 5, 6, 7. That can't be 3, this can't be 6. That can't be 3, 5 or 7. That can't be 4, that can't be 4. Strange, but true. 5 must be in one of those cells. Feels like that's not even necessarily true. I don't know why I said that. I was just looking at the candidates here. Sorry, that's complete balderdash. Right, in these we have 5, 6, 7 and 9. That can't be a 9. We have 3, 5, 8 and 9, but that can't be an 8. This can't be a 9, and in fact these top two can't be 3's because there's already a 3 in the box. So one of those is a 3. We can do the same here. We've got 4, 6, 7 and 8, but 4 can't be down here. It must be up here, and this can't be an 8. I don't know if that's worth doing at all. Right, maybe we have to think about this again. Can we work out if this has a 1 and a 4? If it has a 1, it's obviously got to be in the white cell there. And if it has a 2, it's got to be in the white cell there. Oh, so if it had a 3, the 3 would have to be here. And if it had a 4, don't know. I can't quite see. Oh, this 573. It's a shame they don't include an 8 or a 9, which would limit things quite dramatically in the middle. 1 and 2 have to be here. Oh, 4 in this box is in one of those. That's not very helpful. I want to know which one of these is a 1 and which one's a 2, and I don't know how I can know. Oh, let's have a look at this middle row. I've got 4, 6, 8 and 9 still to place. There's a 4 or a 6 in there. These are also from 4, 6, 8 or 9, because they can't be 1 or 2, which are in the cage. They also, because they're there. But they also can't be 5, 7 and 3. So now we've got a 4, 6, 8, 9 quad here. So these are from 3, 5 and 7. I was going to say, and there must be something from 3 and 7 here, which was going to allow me to determine that. Oh, actually. Oh, no. I was going to say, if there is a 7 here, that's a problem. And that's a problem because that becomes a 4-6 pair to make 10, but this becomes a 6-9 pair to make 15, and that can't happen. So that would have a clash of sixes. So there isn't a 7 there, so 7 is definitely in one of those two cells. I don't know that that helps at all, annoyingly. It's interesting, though. Can we do the same with 3? I don't know, we can't, because it doesn't affect the 15 pair. If 3 was there, this would be 4, 6. That would be 7, 8. And these two would be 5 and 9, and I think that's all right. Oh, so these are from 1, 2, 3 and 5. I think we've worked that out. Because they can't have a 7, that's what we just concluded, and there's a 4, 6, 8, 9 quad there. Oh, come on. Help me, puzzle. It's a very interesting puzzle. I mean, I've been studiously ignoring this 30 diagonal. I just don't see how it can help. 30 over 6 cells is obviously an average of 5 per cell. 5 is also fairly obviously the absolutely average value of a Sudoku cell. So even placing a 1 in this doesn't mean it pushes all the others up to difficult numbers. They could just be anything. I can't see how we get anything done there. Sorry. Where 3 here? Where does 3 go in this row? If it went here, that would make this a 5, 7 pair. And 3 would be here. Maybe it's more about whether 3... Oh, what happened there? Sorry, I'm just going to repair my lighting. My apologies about that. The detailed technical setup doesn't allow me to apparently kick the electrics. Right, sorry about that. Right, now 3. I don't think that was any use. Nothing interesting down there. Oh, it's got to be about these 40 cages. I need to know which one has got a, well, yeah, one of them has got 1 4 and the other has got 2 3. It looks like it would be most helpful and restricting if that was a 2 and that was a 3. Because if that's a 1, there are different places where 4 can go up here. But if that's a 2, there's only one place 3 can go. So that same would be true of 1 and 4 there. So that would be the way around that would be helpful, but I can't see any way to prove it. Oh goodness, what are we meant to look at next? Four, 6, 8, and 9. Only one of those can appear in these cells. So that's not even going to form a quadruple necessarily with those. That can, I don't know, 6, 9, and 8. Can they appear here? I think they can. I don't see why they can't. Oh, I hope I'm not just missing some read across elimination that gets me something. 9 there. So 9's in one of those 2 cells. So 9's in one of those 3. 8 there is the same. 8's in one of those 2 and one of those 3. Just doesn't do anything. 3 is in those 3 cells, but that doesn't confine it in the final column. Wow, okay, need time for a bit of a cold towel and a rethink here. I was making some decent progress and it's kind of ground to a juddering halt now. I'm missing something here. It can't be to do with this 30 diagonal, can it? 4, 5, 1, 10 would leave those to add up to 20. That is easily done. Not seeing anything there. Oh, come on. 3, 4. Oh, no, we knew those added up to 57. That's how we got that these add up to 10. I don't think that's all that useful. Wow, this is tough. Sorry, let me try and come up with something here. I think we're going to need something clever to break through. Is there some disposition of the 1s and 2s that stops things working? Nine, 2, 1, 4, 9. 5 doesn't have to be there. That could be a 1, 2, 3. Then 9 and, well, 9 would then be, well, no, not necessarily there. And that would be a 5, 9 pair. I can't see that that does anything. Right, let's have a think about this 40 cage again then. It's either 9, 8, 7, 6, 5, 1, 4, which puts the 4 here. Or it's 9, 8, 7, 6, 5, 2, 3. But that doesn't fix where the 3 is, infuriatingly. Oh, maybe we need to figure out some cell and where it turns up. Yes, this cell. Yes, where is that in row 2? Can't be in those 3 cells because they're in the same box. Can't be in those 4 because they're in the same cage. And it's not 1 or 2, so it's not there. So that is there. I mean, I don't know. Is that useful? That puts it in one of those 3, but it could be any of those candidate numbers. And I suppose this cell has to be the same down here. That has to be here because it's not 1 or 2 and it's not in this cage. And therefore it's one of these 3. So it's also not 9 because it sees the 9. 3, 5, 6, 7 or 8. What on earth does that do for me? Doesn't do anything. Or does it? This column. It's not 4 because of that. So 4 in this cage, in this box, is now in one of those 2 cells. Now it can be here, and it will be if that's a 1, but it could also be here. But that means it's not here, and that means 4 is in one of these 2 cells and not here. And it's in one of these 3, but it now can't be this orange cell because of the 4 being in one of those 2. So it can't be there. It's not there because of 4 being down here. So 4 is now in one of these 2 cells. And that means it ends up in one of those 2. It can't be there because there's a 4 in one of these. And in the top row, it's either there or there. That sees that pair, that sees that pair, if you like. Now, if this is a 4, it's on the 30 line. I still don't think that helps. If this is a 4, then, this can't be 8 because there's an 8 in one of those cells. Actually, that can't be 9 for the same reason, symmetry. If this is a 4, then this has to be a 9. Oh, that's brilliant. That doesn't work. If this is a 4, this has to be a 9 because 7's not high enough. That's going to make this a 1. Look at that. If this is a 4, you get 9, 1, 2, but that 4 has pushed 4 here, and suddenly you get 2 and 4 in a 40 cage, and that's not possible because they're either missing 2 and 3 or 1 and 4. So that's not 4. Bingo. Absolutely bingalingalo. Right, that's not 4. So the 4 in box 1 is here. So that's not 4. So we get a 4 on the 30 diagonal. Now 5. These have to add up to 25. I don't think that really gets us there. It's still averaging 6. I was hoping it might prove this can't be a 2, but I don't think it does. But surely something else is happening now. Now we took 8 out of there, and these add up to 15, so that's not 7. We took 9 out of here, so we can take 6 out of there. Those 2 add up to 15. I'm still trying to remember. These 2 add up to 10. Oh, and we've taken 4 out of there, so we can remove 6 from there. Now, these cells can't be 1, 2, 3, 4, or 8. They are 5, 6, 7, or 9, but that can still be either of these places. Oh, come on, come on. 4, yes. 4 in this box can't be there because of that 4, and that 4 stops it being there. So it's in the bottom row. It's one of those two, and that means that's not a 4, and this is. And now we've got a 4 in a cage. Oh, actually, we've just also, yeah, okay, I see now. 4 can't be in this cage. 4 is in this cage. So that cage has a 1 in it. This one has the 2. We've got to put a 3 in it. This is the way round that helps. So we get a 3 there. We've got, look at that little 1, 2, 3, 4 quad at points of a rectangle. 1, 1. Oh, that's sorting out all the 1s and 2s, I think. Or lots of them. Maybe not all of them. Let's see. 1, 2. It sorts out all those ones. Doesn't do the ones in rows 4, 5, and 6. But this is in the 14 cage. This can't be a 9 anymore because that can't be a 4. So we've got a 7 here, 8, and a 6 there. Those two have to add up to 10. So that's a 4. This is an 8. That cage works. Those can't be 8. So 8 is now in one of these two cells and in one of these two. Oh, there's no 3 in this cage now, so 3 is ruled out of the blue cells. And there's no 8 either. That 8 actually sees 2 of them out of 2. There's no 3 in the cage, so this is not a 3. There we go. So this is the 3 in the box. Is that working up here somehow? 7. 7 has been ruled out of those two and actually out of the orange cell. 6 has been ruled out of it too by this 6. The orange cell is 5 or 9. Why has the blue cell not come down to 2 possibilities? Don't know, but 5 or 9, it could be that, but it could, oh, this can't be 6. 3 in the top row has to be here. That is 5, 7 or 9. No, there's only one plate. That's a 5, 6, 8, 9 quad. So this is 7. So one of these is 7, which is interesting because 7's not in these cells. That's a 5, 6, 9 triple. So we get 7 and 8 placed. This blue can't be 7. That's down to 2 cells. So that one is blue. This one is orange. Don't know that that colouring is going to do any more. We've got a 5, 8, 9. Oh no, that's 5 or 9. So these two can't be 8 because that's in the orange cell and can't be 8 over here, and that one sees that. So we can fill in 8 here. That's a fascinating puzzle. 6, 7, 8, 4. I don't think column 1's doing anything. This is letting me put a 7 in this column there. That is 5 or 6 as well, forms a pair, so that's not 5 or 6. Oh yeah, look, there's a pair, a 5, 9 pair, so that's not a 5. There's a 5, 9 pair there. In fact, this is a 4, 6, 7 triple. Now, let's keep constant. Look, 5, 6, 9 in the cage as a triple. So that's where 8 goes in the cage. That doesn't fix 8. Puts 8 in one of those two cells. 6 and 8. Oh, here somewhere. Oh, look, that is the last cell in its column. That's quite an easy one to fill in. That's not 6. Now we've got a 5, 9 pair there. Yes, 8 is seeing both of them. So this is where 8 goes. Is this finished down here? Don't think it is. We've lost the symmetry a bit somehow. Maybe because I've missed something. Now, remember this H-shaped cage. 8 and 4 are confined in there. 7, no, 7's there. Bother. 7 was the given. In fact, let's highlight the 7s. There is a 7 in one of these two cells. That doesn't help. Right. 8, 4, 2, 7, 1. 4 and No. Five, 6, and 9. There is a 6 there, and there is a 6 here. So that's a sort of X-wing and makes it definite that there's a 6 in one of those two cells. So that is either 3 or 7, actually. That's the simpler way to use that. That's a 3-7 pair. So we've got a 5-6-9 pair over here, and this must be a 3. That's much more straightforward. And that means this is now a 5-7 pair. And there's no 5 here. That's a 1-2-3 triple. And that doesn't advance. But, of course, the diagonal. 13 there. These have to add up to 17. What can this be? 2, 5, 7, or 9, I think. No, it can't be 7 or 5 because they're in the cage already. That is 2 or 9. So, yeah, I don't know. What these have to add up to 17, don't they? If that was a 2, these would add up to 15, but they could be 9, 6, or 8, 7. If that's a 9, these add up to 8. I don't think they can do that. No, they can't. There's no way for them to add up to 8. So that is a 2. And that's going to fix all the 1s and 2s. 2, 3, 1. There's a 3 in one of those two cells. Let's do the last bit of green colouring just for fun. But this one is not a 1. So, is that all that does? No, the diagonal. 10, no, 12, 13, 15. These two now add up to 15. So they're either 9, 6 or 8, 7. I don't know which, but surely we've got something else to go on. This can't be a 3. So that's a quad. The 3 in the column is here. Yeah, because of the 3 being removed from here on the diagonal. So this is a 3, I think. That's the last 3 in the grid, in fact. That places 8 in this row. That can't be 8. But the cage, the big H cage, needs an 8. That goes in there. Is that placing 6 here? Not necessarily. This can be a 6 still. This is where 9 goes in the box. Yep, that's right. So the orange cell becomes 5. That's a 9. That's a 9. That's a 9. The blue cell becomes 6. 5 and 9 get filled in. Surely we can do these two, 9 and 5, and this 5. Can we do this? That's a 4. Oh, and a 6, 7 pair left over somehow. I thought we were going to finish all of rows 1, 2, 3, 7, 8, and 9, but not quite. This can't be a 5. Never could. Look, it's got a 5 and a 7 in the cage, so that's a 6. And this 4, 9 pair is resolved, and I think we are finished now. That's a 6. This is 7. That's 6. 4, 7, 5, 7, and 1 number to do. And there we go. What a lovely puzzle. Really good stuff from Sotek there. And I think the inner sanctum was probably this area of digits that we were able to fill in fairly early, but there was a lot of work to do. I mean, that's a very elegant puzzle. Oh, it's this trick of finding a digit that can only be in one place, spotting that that one was there. That's hard. It certainly helped to identify the totals by doing a lot of adding early on, but it didn't quite finish it off. Really interesting puzzle, lovely ideas there from Sotek. I hope you had a go at that and enjoyed it. I certainly did. And I hope to see you again on the channel for more Sudoku solving tomorrow. Bye for now.